So good morning everyone present. I am Parmat Mundra and I would be presenting my topic on human activity identification suspicious behavior detection system. So, and it's an honor to be present over here. I thank all the organizers for giving me this opportunity. Moving forward, this is the overview of how we will be proceeding with the presentation today. Moving on to the next is the introduction. So as we know that nowadays the image recognition process as well as the image processing process has been the boom and the challenging area in the research of for computer science engineering. So using human activity recognition, it plays a very important role in human to human interaction and interpersonal relationships, because using activity recognition process, we can improve the conversation between the machine and the human beings, and we can improve the relationships between the humans and machines. So these human activity recognitions and suspicious behavior detection systems have various plenty of applications, which include security and surveillance, sports analysis, and healthcare. Then moving on to the abstract, this is the abstract of a paper. In a paper, we have proposed a system which utilizes a cust-based framework to identify human actions using skeleton data, where the data set is of human being with its all the joints points. The data set is with of the joints point, in which we have the points of hand gestures, we have the points for shoulders, we have the points for face detections and everything. So that is called as skeleton data. We use skeleton data to identify the activity performed by the human being, and we use a single stationary camera input in a system to identify the real-time activity performed by the human being in the front of a webcam or a particular single stationary camera. And the recognition process takes place using machine learning. In machine learning, we use various algorithms to identify the human action and the suspicious behavior. Then our model utilizes to identify human activities such as sitting. We propose a system to identify various activities such as sitting, running, walking in the human activity field, and in suspicious behavior, we find out the fighting and the robbery scenes. Moving on to the motivation, why did we select this project idea? Because nowadays, as we listen in news various times in the current affairs as well, that many unexpected scenarios occur, that many of us are very danger because of some suspicious behavior. Many complaints are being registered. So for that is why we selected this topic, so that we can have an look over how the suspicious behavior have been performed, and we can take some actions to improve the security or the safety of the public people. So in recent times, humanity has been subjected to unforeseen occurrences and mishaps which have resulted in significant loss of life. So this is what was the motivation which dragged us to selection of this topic. And the problem statement for a paper is recognizing human actions has been one of the biggest challenge in computer visions. So identifying human activity and behavior is the main challenge, and detection of all these various activities. So I was over here in problem statement. The problem statement of our paper was to identify the various human actions, which were walking, sitting, standing, waving, robbery, fight, and knives. And using identifying these activities, we used machine learning problems. So our main objective for a project of our system was to accurately recognize the various activities and suspicious behavior to improve the public safety. The system was also the main motivation, the main objective to create a system was to be scalable and cost effective, so that it can be implemented with very less even who have very less idea on how to improve that security for the shop as well, so that robbery may not take place, or if it take place, they can have an access on the, or they can have an eye on how was it done. So real-time processing capabilities to ensure timely detection and response to suspicious behaviors was our objective to find out. So this is how our system will be working. This is the system architecture. So here you can see that we have a training image and a video data set. So as I mentioned, the data set of our project is according to the data points. It's according to the joint points of a human being, the shoulder points, the finger points, the elbow points, and the human body or the face detection points. Then for the suspicious behavior system, we have we have a video input through which we give the video to the model, and from the video it extracts the frame, or it extracts the features using those data points, using those joint points, and it identifies the behavior which has been performed by the person, or the activity which has been recognized which has been performed in the live web camera. So once the model is trained, the user is given the user has to give the permission for the camera, for the live camera, and then once the live camera is on, he can perform his activity in front of a camera, and those active will be after some time, as he performs the activity will be recognized, and the model will be recognizing the activity, and once the threshold percentage of matching of those points has been overcome, the system will show you the percentage with the accuracy of how much accurately you have performed that particular activity, and then the display of the output will be shown. And for the suspicious behavior, if the suspicious behavior happen or occur in a video provided by us, the system will generate an alert message, which will further be given to the owner of the system or to the security, for the security purpose. An alert message will be shared on the registered number on the registered number portal, on the registered number on the portal, so that you can take particular action on the some suspicious behavior action. And moving on, for our project we use three algorithms. One is logistic regression. As we know, logistic regression is a classification algorithm which gives us the probability in 0 and 1, which gives us the probability of whether the activity is happening, yes or no. So logistic regression uses a probability based approach to identify the percentage of with the accuracy, the percentage of the activity being occurring and not occurring. And then random forest classifier, we use random forest classifier to make a decision tree, various decision trees, so that we use random forest so that we can use it for the complex data as well. In the future case scenarios, if we have a complex data set, and so we can use random forest classifier, so it can make various decision trees and can take decision on the basis of those decision trees. Then conventional neural network is for the suspicious behavior detection system, where we provide an input of video data set, and where the frames are being extracted according to the features we want, according to those joint points. And once those joint points are matched with the features we wanted to extract, then on the basis of those feature extraction points, it will compare with the data sets, and it will let us know which suspicious behavior has been occurring. So the application of our systems are in security surveillance. We can install it for the shopkeeper, so that they can have an eye on if there's any suspicion or any robberies happening in that shop or not. We can use it for healthcare monitoring, where in healthcare monitoring we can implement it for taking care of old people, so that if they are performing some activity, we are telling them to perform some activity, and they are keeping a human being for 24/7 hours to keep an eye on them when they are performing an activity is a it's a costly process. So using a system, we can keep an healthcare monitoring on older people, or we can keep an eye on them of what activities they have been doing. On the sports analysis, we can use it on sports analysis by analyzing the athlete's performance, or how he's performing, and we can improve its performance. In human computer interaction, if once the machine is able to recognize the human activity, it will be easier for both for machine as well as for human beings to communicate with each other. So for human computer interaction, we can implement this. And for smart homes, we can use gestures of human activity to improve our functionality in smart homes. So coming to the conclusion, so in conclusion, the development and evaluation of human activity identification shows the promising result and identifying of human activity behavior. The system has achieved, our system has achieved high accuracy, and it's sensitive to sensitive to a small amount of. It sees the precise joint points and give us the actual a particular activity being performed. And overall, our system is robust and scalable solution for activity recognition. For future scope, even for moving further in future, we can integrate a system with IoT devices, Internet of Things devices, so that using IoT devices, we can integrate in for the use of smart cities. In smart cities, whereas in the public areas, where we are able to keep a surveillance eye on those, and we can use multimodal data fusion. What is multimodal data fusion is, with the camera, currently we are using the camera as an input. We can even use various sensors, microphones for as input, so that we will be able to more recognize and find out more activities correctly and accurately, with more accuracy. We can improve our accuracy of our model using multimodal data fusions. And so these 6 papers were references we took from. We took an idea from those, and we tried to implement with our own ones. And so these were the references we used for a presentation. And yes, sir, now I'm free for questions and answers.
Yes, your presentation is very nice. But I am asking to first query from my side. You are using you are working on the detection image processing based detection system, right?
Yes, sir.
Okay. So you are working on a detection of the some human being action like walking, sitting, standing, waving, fight, etc. Right. So
Yes, sir. Yes.
how will we maintain the all the properties, all the types of the image processing like visualization, recognition, sharpening, and distorting and pattern recognition? How will we maintain all these properties in your research, in your research
So, sir,
project?
so, sir, for maintaining all those properties which you mentioned, so, sir, the initially when we will train the model, we will be giving it the data points. For example, if I take a sitting data point, for example, if I'm performing a sitting activity, so my all the body points, like for the shoulder, for the knee points, or for the face point, or for the chest point, all those points will be recorded very precisely in a data set. And we comparing those data set with the live camera, we use OpenCV module, in which in using OpenCV module we will be able to lively match all the data points of the person performing activity, and through that we will be able to accurately with the precisely we will be able to find out the activity performed by the person. So keeping the all the features all together with onto the data set point on the body points, we will be able to do it, sir.
Prepare the data set for your work.
Yes, sir, I can show you the data set.
My another question.
Yes, sir.
You are using a logistic regression model or using a CNN algorithm. So, how can we apply the logistic regression method for your walking and sitting action?
Sir, so as we know that logistic regression is a classification process. So using we will first divide a data set into training data set and testing data set. The label data set which we have. So once the model is been once the data has been separated, so we'll train a logistic regression model on the base of training data sets, where if the data points of a person matches to the particular joints points of all the human body parts, so once those data points matches with the training data set, when we give a testing data set or the live camera data set, so it will match the all those data points in logistic regression. It will provide us with an 0 to 1 probability once the minimum threshold value, for example, if a 50% or 75% of minimum threshold percent of accuracy has been provided to the system. So once those threshold overcome, so logistic regression will be able to identify that activity if the activity is performed above that threshold value, and then it will and then it will detect the activity. If not, if the threshold value is not if not overcome by the system, then the activity won't be the activity will be detected, but with the less accuracy, where we get a number very closer to zero. If the accuracy is high, then the number we will get the number closer to 1.
Okay, so in your work, they required IoT devices also for prepare the real-time data set, right?
Yes, in the future scope, yes, sir.
So how will we collect the real-time data set by using the IoT devices, and which kind of the IoT devices that will you use for your work?
So, sir, we can use the motion sensor detection, motion sensors in IoT devices, where we can use motion sensors, and even we can use the sound detection sensors as well. As I mentioned in multimodal data fusion, we can use sound for the as well as activities together. We can merge them together, and we will be able to improve the accuracy for the systems.
Okay, good. Thank you for joining. Thank you.
Thank you, sir.
So this is my side, sir. Over to you, sir.
Okay, thank you. It was indeed a very good presentation.